Hello everybody, my name is Narayan Sharma, and in this video I am going to talk about nomenclature of organic compounds. So in this topic we'll be discussing about different rules that are given by International Union of Pure and Applied Chemistry, simply called IUPAc, to name the organic compounds. So before going through the rules, we'll have to have some general idea about other simple topics as well. This topic include organic compounds, and then hydrocarbon, and then functional group. All right, so let's now start with our first topic, that is organic compound. So what are organic compounds? Organic compounds are those compounds which contain carbon. So compounds that contain carbon are called organic compounds. For example, CH3CH3, CH3CH2OH, CH3COOH. So these all compounds contain carbon. That's why these compounds are considered as organic compounds. However, there are some exceptions as well. There are some compounds which contain carbon but not considered as organic. For example, NaCN, CaCO3, CO2, CO, etc. Right? So these are the compounds which contain carbon but not considered as organic. Right? When organic compounds contain carbon and hydrogen only, these are called hydrocarbons. All right, so hydrocarbon means those compounds which contain carbon and hydrogen only, and hydrocarbon can be either branched or unbranched. For example, this. Okay, so here first two compounds are unbranched one and second two compounds are branched one. So we can easily separate whether the compound is branched or not by looking over the compound. Here in this compound, one carbon is connected with at least 3 carbon. All right, so here no carbon is connected with 3 or more carbon. All right, so in case of branched one, at least one carbon must be connected with at least 3 other carbons. All right, then we call them branched one. Based on the nature of the bond in between the carbons, hydrocarbon can be either alkane, alkene, or alkyne. Hydrocarbons can also be classified as alkene, alkane, and alkyne. All right, for example, here we have a single bond in between the carbon. That's why we call those kind of hydrocarbons as alkane. If we see double bond in between the carbon, then we call them alkene. And if there is triple bond in between the carbon, then we call them alkyne. There are some examples. Ethane is an example of alkane, ethene is an example of alkene, and ethyne is an example of alkyne. All right, that is about the hydrocarbon. Organic compounds can also contain other atoms in addition to the carbon and hydrogen. Organic compounds can also contain other atoms in addition to carbon and hydrogen. Such organic compounds are said to contain functional group. So what are functional group? Generally, an organic compound contains two parts, hydrocarbon and functional group, like this. Here, R represents hydrocarbon, whereas X represents functional group. So for example, CH3CH2 is a alkyl group part, that is hydrocarbon part, and OH is a functional group part, that is alcohol. Similarly here, NH2 is functional group, which is amine, and CH3CH2 is a hydrocarbon part, which is alkyl group. So in our example, although the two compounds contain same hydrocarbon part, these two compounds contain same hydrocarbon part, but their physical and chemical property are different. This is because they contain different functional group. That means functional group is an atom or group of atom that determines the characteristic property of an organic compound. All right, so functional group determines the characteristic property of organic compound. So the table below shows the different functional groups with their structure formula. We should know about this list. All right, table continues like this as well. So here if we see OH group attached in the carbon, then the functional group is called alcohol. For CHO we call aldehyde. For CO group in between the carbon, then we call ketone. Similarly for COOH we call carboxylic acid. Oxygen in between two carbon, that is called ether. All right, so these are the functional groups. Now let's move to the IUPAC system of naming the organic compound. Alright, so according to IUPAC, the name of any organic compound can have following parts in the following order. So the name of organic compounds can have the following parts. These parts are prefix, word root, primary suffix, and secondary suffix. Name of organic compounds can have either all the four parts or some of them depending on the nature of the compound. For example, this compound contains only two parts, word root and primary suffix, but this compound contains all the four parts, prefix, word root, primary suffix, and secondary suffix. Alright, so based on the nature of the compound, the name of compound can contain either two parts, three parts, or four parts. Right? Now let's see what each of these parts in a name of organic compound indicates. Let's start with word root. So word root indicates the number of carbon in the parent chain. Right? Number of carbon in parent chain. So what is parent chain? So in case of unbranched compounds, there is only one carbon chain, which is considered as parent chain. Right? In case of unbranched, we just discussed about the unbranched and branched hydrocarbon. So in case of unbranched compound, there is only one carbon chain, which is considered as parent chain. For example, the following compound contains 4 carbon in its parent chain, 1, 2, 3, and 4. So that's why this is the parent chain, and the parent chain contains 4 carbon in case of this compound, which is unbranched one. In case of branched compound, there are more than one carbon chain. So we use a rule called longest chain rule to determine which one is the parent chain. So if there are 2 or more chains available, then we should determine which one is the parent chain, and then only we can count the carbon in that parent chain and to decide the word root. Here is the longest chain rule. So for hydrocarbon without functional group, the chain containing the greatest number of carbon is taken as parent chain. For example, here in this example we can see if we go through like this 1, 2, 3, 4, 5, we have 5 carbon. If we go through like this 1, 2, 3, 4, we have 4 carbon. So this is the parent chain, and this is not a parent chain because the chain containing the greatest number of carbon is taken as parent chain. That's why this is a correct selection, and this is incorrect selection. Similarly, in this case, CH3, CH, CH2, CH3. So this chain contains 1, 2, 3, 4, and when we go through like this 1, 2, 3, this chain contains only 3. That's why this becomes incorrect selection, and this becomes correct selection. All right. Now, for hydrocarbon containing functional group, all right, if there is a presence of functional group, then the longest chain containing the functional group is taken as parent chain. We should take that parent chain which contains the functional group. All right. For example, in this case, when we go through like this 1, 2, 3, 4, we have 4. When we go through like this 1, 2, 3, 4, 5, but this arrangement or this selection is the correct one because this chain contains the functional group. That means when we see functional group in a compound, then we take that chain which contains the functional group as a parent chain. All right. Similarly, in this case 1, 2, 3, when we go through this becomes 3. When we go through like this 1, 2, 3, 4, this becomes 4. All right. So here although there are only 3 carbons, but it contains the functional group. That's why we take this chain as the parent chain, and this selection is the correct one. Right. That is about the longest chain rule and how to select the parent chain. So in unbranched compound, there is only one chain, and which is considered as parent chain. But in case of branched compound, we should use the longest chain rule, and the longest chain rule can be used in 2 cases. First, for the hydrocarbon without functional group, we take the longest chain, we take the chain which contains the largest number of carbon, and for functional group, a hydrocarbon containing functional group, we should take that chain which contains the functional group as parent chain. All right. So that is about the selection of the parent chain. Once we select the parent chain, once we decide the parent chain, we use the following table to assign the word root. Alright, so word root means number of carbon in the parent chain. So we already decided the parent chain. Now we are going to the word root. How to assign the word root for given number of the carbon. Alright, so for 1 carbon we use meth, for 2 carbon in the parent chain we use eth, for 3 carbon in the parent chain prop, similarly but, pent, hex, hept, oct, non, dec, undec, dodec, like this. Alright, so that these are the word root which are used for a specific number of the carbon in parent chain. Alright, so that is about the word root. We can also see an example over here. Here in this compound we have 1, 2, 3, 4 carbon in the parent chain, because this is considered as parent chain, as this chain contains the functional group. All right, and in this parent chain we have 1, 2, 3, 4 carbon. That's why the word root is but. All right, that is about the word root. Similarly here 1, 2, 3, 4, 5, sorry, 1, 2, 3, 4, 5. That's why we use pent. In this case there is no functional group, that's why we take that chain which contain the largest number of the carbon. All right, that's why the word root is pent. Let's move to the another part of the name, that is primary suffix. So what is primary suffix? So primary suffix indicates the nature of bond in between the carbons, right? Nature of bond in between the carbons. So the list of the primary suffix is given below in the table. If we see single bond in between the carbon, then we use ane as a primary suffix. For double bond we use ene. For triple bond we use yne. And for single and double bond we ignore the single bond, that's why we use only ene, that is the primary suffix of the double bond. And if we see double and triple bond, then we should write both ene and yne, but in alphabetical order. Here is also single bond, but single bond is always ignored if there is a presence of the double or triple bond. All right, so if we see 2 double bond, then use diene, 3 double bond triene, 2 triple bond diyne, 3 triple bond triyne, like this. All right, these are the primary suffix which can be used after the word root in the name of organic compound. All right, so for example here let's talk about the first example. Now CH3 CH2, there is a single bond, that's why we use ane. For 2 carbon eth, for single bond ane. All right, here we have double bond, that's why we use ene. We have triple bond, that's why we use yne. We have 2 bonds, double and triple, that's why we use ene as well as yne. All right, this is the example. Now there is one extra rule. That rule says if primary suffix begins with the consonant letter, then an extra a is added after the word root. Right, primary suffix begins with the consonant letter. Right, for example here in this case the primary suffix is starting with d. D is the consonant letter diene. All right, so for this we have to add extra a to the word root. So word root is here 1, 2, 3, 4 but, but we write here buta because extra a is added. Why? Because we have primary suffix that is starting with consonant letter d. All right, but here in this example ene, so eth only, not ether. Okay, so ene here eth only, not ether. Right, so that is about the extra rule that is generally used if primary suffix starts with consonant letter. Now let's talk about the secondary suffix. So secondary suffix indicates the presence of the functional group in a compound. So what is the functional group in a compound? The following table shows the list of the functional group and their secondary suffix. So we already discussed about functional group, atom or group of atom that is present in the hydrocarbon and determines the characteristic of organic compound, that is a functional group. So for what functional group what is the secondary suffix? All right, so here if we see alcohol in our compound, then we should write OL as a secondary suffix. For aldehyde we should write AL. For ketone YNE. For carboxylic acid weic acid. For ester OH. For amine amine. For amide amide. For nitrile nitrile. For thiols and thiols, like this. All right, so if secondary suffix starts with the vowel letter, then E of the primary suffix is removed. The secondary suffix is generally written after the primary suffix, right? So if secondary suffix starts with the vowel letter, then E of the primary suffix, generally primary suffix ends with E, ene, yne, ane, diene, triene. So the last letter, that is E of the primary suffix, is removed whenever whenever the secondary suffix start with the vowel letter. For example, so we have OS group, that's why we use OL. First of all, that is the point for secondary suffix. And then if we are using OL, then O is a vowel letter, that's why the E of the primary suffix, that is ane, E of the ane is removed. That's why the name is ethanol, ethanol. There is no E present. Okay, E of the ane is removed. Similarly here we have oic acid, and that's why E is removed. So propanoic acid. So that is about the secondary suffix. So what if we have two or more functional groups? All right, we write the name of functional group in the secondary suffix. But if there are two or more functional group, what we can do? So if there are two or more functional group, we cannot write two or more secondary suffix. All right, so for that we use polyfunctional rule, right? So what is polyfunctional rule now? So polyfunctional rule says, according to this rule, for a compound containing two or more functional groups, one functional group is selected as a principal functional group and indicated by secondary suffix, and all other functional groups are considered as substituent and indicated by prefix. So according to the polyfunctional rule, only one functional group is considered as a principal functional group and indicated by secondary suffix, and other functional group is considered as branches or substituent and indicated by prefix. That means we can write only one secondary suffix for one functional group, and other functional groups should be written in the prefix. All right, that is about the polyfunctional group. Now, how can we select which functional group is considered as a principal functional group and indicated by secondary suffix? For that, we use a rule called priority order. All right, we use a rule called priority order rule, and according to this order, when we see a compound functional group that is that has the most priority, then we use that functional group as a secondary suffix. All right, the selection of the principal functional group is done by using a priority order as given below. So first priority is given to COS group, followed by COR, SO3H, COX, like this. All right, so in this order, if we see any group getting a more priority than other, then this group is considered as a principal functional group and indicated by the secondary suffix. Let's see some examples over here. In this example, we have two functional groups, COOH and OS functional group, right? So for COH and OH, we have COH over here and OS over here. That's why COS is getting priority. That's why COS is equal to principal functional group and OH acts as a substituent or prefix. That's why we use oic acid. Oic acid is a secondary suffix of the COS group. We cannot use OL because OS is the substituent here. Similarly, another example we have here two functional groups, NH2 and OH, and among these two, NH2 is here and OH is here, so OH gets priority. That's why OH is a principal functional group and we use OL. All right, we cannot write amine here. All right, so because NH2 group is acting as a substituent, it is not getting priority for this compound. However, there is some exceptions. Two functional groups, halogen and ether, are the two functional groups that are always indicated by prefix rather than by secondary suffix, no matter if they are present alone or with other functional group in a compound. There are two functional groups, that is halogen. Halogen includes fluorine, chlorine, bromine, iodine, and other functional group is ether. All right, this is oxygen in between the two carbon. All right, that is called ether. So these functional groups are always considered as prefix. Always considered as prefix. All right, they do not have their secondary suffix. Okay, so let's now talk about prefix. So what is prefix? The prefix indicates the presence of substituent in the compound. Alright, so presence of substituents or brands in the compound is indicated by prefix. The substituent can be present in the following three cases. Actually, how can we separate? How can we know whether there is presence of substituents or not? So we can use the following three cases. Okay, first one is if a compound is branched, then there must be a presence of substituents. If a compound contains halogen or ether, we use prefix here also. And if compound contains two or more functional group, then there is also presence of substituent and we use prefix. Alright, so if compound is branched, then possible substituents and their prefixes are the substituents might be like CH3, CH3CH2, CH3CH2, CH3, CH3, 2CS. Alright, and the prefix for those substituents are methyl, ethyl, and propyl, isopropyl, like this. For example, in this case, so by using the longest chain rule, we selected this chain as a parent chain. That's why this chain contains 1, 2, 3, 4 carbon. So but is the odd root, single bond is amine, there is no functional group, and this CH3 becomes a substituent. And for this CH3 we use methyl. Alright. If compound contains halogen or ether, then possible substituents and their prefixes are for CH3O we use methoxy, for CH3CH2O ethoxy, for fluorine, chlorine, bromine, and iodine we use fluoro, chloro, bromo, and iodo respectively. For example, in this case we have Cl, that's why we use chloro. For 3 carbon we use pro. For single bond we use ane. Here we have CH3O, CH2, CH3. So by using the longest chain rule, CH3, CH2, CH3, CH2, CH3 gets the priority. That's why this acts as a parent chain. And for 2 carbon we use 8, for single bond ane, and OCH3 becomes substituent, and for OCH3 we use methoxy. That's why the name is methoxy ethane. Alright. Now, if a compound contains 2 or more functional groups, then possible substituents and their prefixes are. If OH comes as a substituent, then we use hydroxy, and for CHO we use aldo, for CO we use keto, for CN we use cyano, for SO3H we use sulfur. For example, here we have 2 functional groups, COOH and OH. Here COOH is getting priority, that's why COOH group is indicated by secondary suffix, that is weak acid, and OH is indicated by prefix. And for OH we have hydroxy, that's why we use hydroxy. Alright, so the name is hydroxy butanoic acid. Okay, so let's now talk about the positioning the substituents. So positioning the substituents means provide the prefix with the number. Alright, so we need to give position of substituents and functional group when necessary. So what is that necessary condition? It is necessary to give position when giving the position is the only way to separate the name of isomers. Isomers have different physical and chemical property but same molecular formula. But if we need to separate the name of isomers, then we need to provide them with position. Alright. For example, here these 2 are the isomers. Alright, these 2 are the isomers, and in these 2 compounds the difference is the position of CH3, that is a substituent. So if we change the position of substituent, then the isomer with the same name is not possible. In this case, if we change the position of CH3, then the compound becomes butane. Alright, the initial compound was methyl propane and a new compound was the butane. Although these 2 are isomers, their name are different. Alright, so if there is a possibility of the isomers with a different name, then we don't need to provide the substituents. However, in example here, in example 2, these 2 compounds have the same name, methyl pentane and methyl pentane. However, these 2 are the isomers. Isomer means these 2 are the different compound, because in these 2 compounds there is a difference in position of CH3. If we change the position of CH3, there is a formation of compound with the same name. in that scenario we must use the position of the substituent. That's why we use here 2-methyl and here 3-methyl pentane. Alright, so that is the condition for positioning the substituents. Now, how to give the position of the substituent then? Alright, so the position of the substituents are given by using two rules. There are two rules to provide the position to the substituents: the lowest position rule and the lowest sum rule. There are two rules. Okay, now first talk about the lowest position rule. So lowest position rule can be discussed in two conditions: first for the compounds without functional group, and second for the compound with functional groups. For the compounds without functional group, we start the numbering from the end so as to give the substituent lowest position. So we should start numbering from that end, which will provide the substituent lowest position. Alright, for example, if we start from this end 1, 2, 3, 4, the methyl groups gets 2 position, but if we start from this end 1, 2, 3, 4, then methyl group gets 3 position. So according to this rule, we need to provide 2 position rather than 3, because this is the lowest number. Similarly, for a compound having functional group, we start the numbering from the end so as to give the functional group lowest position. So if there is a presence of functional group, we need to provide the functional group the lowest position. For example, over here, there is a CH3, this is a substituent, and here is a OH, this is the functional group. Although, if we count from over here, 1, 2, 3, CH3 will get 2 position, and from this end, CH3 will get 4 position. That's why 4-methyl, and that's why 2-methyl over here. But the correct positioning is this, because here we have OH group, and if we have functional group, then we should provide the functional group lowest position. Now, there is another rule, that is lowest sum rule. And this rule is basically used when we need to provide 2 or more positions. Alright, if we have more than one substituents, we have to assign position to all of them, and the numbering should be done in a way that sum of all the position is the lowest. Alright, so we try to get the lowest sum of all the positions. Alright, and if there are 2 or more than 2 prefixes, we write them in alphabetical order, and for 2 or more same substituents, we use di, tri, tetra, and so on. For example, for this compound, there are 2 methyl groups, that's why we use dimethyl, and the position is, if we start from this end 1, 2, 3, 2 and 3, if we start from this end 4 and 5, and 2 and 3 are preferred, and this is the correct position, and 4 and 5 is not taken. Right? Similarly, in this case, there are 2 substituents, Cl and CH3, and for Cl we use chloro, for CH3 we use methyl, so chloro comes first and then methyl, and the positioning should be starting from this end, because it will give 2 and 4, and if we start from this end, it will give 3 and 5, so 2 and 4 are preferred. And in this case, here we have written methyl before the chloro, and this is incorrect, because these 2 names are not in alphabetical order. Alright, so this is how we can provide the position of the substituent. Let's now talk about how to practice writing the full name. Okay, so once we have knowledge that we studied till now, that is about the different rules that are required to name the organic compound, we can practice to write the full name, full IUPAc name of a given organic compound by using the following steps. The first step is we have to see whether the compound is branched, containing halogen or ether, or having 2 or more functions. Okay, so these 3 things are very important to notice whenever you first see the compound. Okay, so whether it is branched, whether it contains halogen or ether, or it contains 2 or more functional group. Alright, then now determine the parent chain and substituents by longest chain rule or polyfunctional rule. Okay, so whenever we have the branched compound, then we use longest chain rule to determine the parent chain and the substituent. And whenever there are 2 or more functional group, you use polyfunctional rule to determine parent chain and the substituent. Alright, and if there are halogen and ether, also we use longest chain rule. to determine the parent chain and the substituents. Alright, now after that, write the parts of the name in the order below. Now let's just start writing the name. Okay, so we have the parent chain, we have the substituent. So we can write prefix and then word root. We can count the number of carbon in the word root, and then primary suffix by looking after the nature of the bond in between the carbon, then secondary suffix by looking over the functional groups. Alright, then see if the primary suffix starts with consonant or secondary suffix starts with vowel. Whenever primary suffix starts with consonant letter, then we use extra a to the word root. Alright, and if secondary suffix starts with the vowel, then we remove the e of the primary suffix. So use these rules. If primary suffix is starting with consonant letter and secondary suffix is starting with a vowel letter. Alright, after that give the position of the substituents, and finally you can give the position for the substituents and a functional group if needed. If needed means if there is a requirement. Alright, so to give the position we use lowest position rule and lowest sum rule. Okay, once we are done with this, we can easily write the name of the organic compound. Here are some practice questions for you. These questions are actually classified into 7 different types, each containing compounds with different nature. For practice type 1, we have simplest compounds which neither contain branches nor functional group, and practice type 2 contain the compounds which have only branches, and then we have practice type 3 which contain a single functional group, and for practice type 4 we have the functional group, but these functional groups are always used for prefixes, and for practice type 5 we have the compounds which contain branches and a single functional group. Similarly, we have practice type 6, and in this type we have the compounds containing 2 or more functional group. We probably use polyfunctional rule over here. And for practice type 7, it contains the most complex compounds which have branches as well as 2 or more functional group. So these are generally the types of questions you can practice. Okay, so before going through the practice of those questions over there in practice section, I want to review some of the summary of IUPAc system. So once we have that background over here in the content, then we can easily practice the name of the compound, right? So summary of the IUPAc system of nomenclature says name of an organic compound contains 4 parts. So prefix, word root, primary suffix and secondary suffix. Prefix indicates branches. Word root indicates number of carbon in parent chain. Primary suffix indicates nature of bond, and secondary suffix indicates functional group. And for different branches we have here prefix. For different number of carbon in the parent chain we have word roots. For different type of bond we have primary suffix. For different type of functional group we have different secondary suffix. Alright, and in addition to those we also need some rules over there. For example, here we have to know about longest chain rule for branch compound. Alright, to select the parent chain, and once we select the parent chain we can use this list to indicate the word root, and then there is an extra rule, that is a added if consonant in PS. That means if primary suffix start with the consonant letter, then an extra a is added to the word root. Alright, and then e is removed if vowel in SS, that is in secondary suffix. If there is a vowel letter, then we have to remove the e of the primary suffix. Alright, and similarly if there are 2 or more functional group, then we use polyfunctional rule. And if there are halogen and ether, these are always indicated by prefix. And for positioning the substituents we use lowest position rule and then lowest sum rule. Alright, so this is the summary of the IUPAc system of nomenclature. So once we have the knowledge of this summary, then we can practice naming the compound by using these steps over here. So these steps include, first we have to identify whether there is branch, polyfunctional groups, or halogen or ether. Then we need to determine parent chain and substituents, then start writing the name in the given order, and then finally we can use, if there is the possibility of using any type of rules such as removing the E or adding the A, and then finally positioning the substituents, all right, by using the rules, that is lowest position rule and lowest sum rule. Okay, so now I'm going to take some examples over here and start writing the name following these rules. Okay, so for that I want to take the question from here in a practice section, and let me just randomly pick a question that is like this. Okay, so I want to pick this question over here. This is the question. This is the question. I'm going to write the name. Okay, so let's say this is our question. All right, so we're trying to write the name of this compound. So first of all, we have to determine whether the compound has branch, functional group, or halogen or ether. So this compound has branch because this carbon here is connected with at least 3 other carbon, and similarly another carbon also connected with other 3 carbons. That means this compound contains branch. Okay, once we determine whether the compound is branch or not, then we determine the parent chain. So parent chain determination is done by using a longest chain rule. So let's try this. Okay, so if we count like this, 1 2 3 4, this will be 4 only. 1 2 3 4 5 6, this will be 6. 1 2 3 4 5 6 7. So if we go through like this, 1 2 3 4 5 6 7, then this is the longest number of carbon, that greatest number of carbon. Then we should choose this chain as a parent chain. All right, so this, let me indicate this by the bracket. Okay, and then this. Okay, so we move like this. That means, and this is our parent chain. All right, the parent chain contains 1 2 3 4 5 6 and 7. Okay, then we have 2 branches over here, left, right. So determine the substituents. That means these are the substituents. This becomes now substituents. So 2 substituents. Now start writing the name. Okay, so we start writing the name like this. So first we should write prefix, and then word root, primary suffix, and secondary suffix. So for prefix we have 2 substituents, right, CH3, and for CH3 we have methyl, and there are 2 CH3. That's why we should write dimethyl. All right, so it will be dimethyl, and plus then dimethyl, and then word root. Okay, for word root we have to count the number of carbon in parent chain. 1 2 3 4 5 6 7. So we have hept. Okay, for 7 we have hept, and then plus primary suffix. So there seems single bond, that's why we use ane, and then plus secondary suffix. For secondary suffix there is no function group, that's why we don't need that. Okay, so methyl, dimethyl, hept, ane. All right, and now once we have done with the done with this third step, then we should see whether primary suffix start with consonant letter. No, it's in vowel letter, and there is no secondary suffix, so we don't need to worry about these steps. Now finally give the position of the substituents and functional group if needed. There is no functional group, we need to give the position of the substituents, because if we change the position of the CH3, there is a formation of the new isomer, but the isomer would have the same name. You can practice this by writing by your own, and then let me just give the position over here. So for giving the position we have 2 possibilities, right, and these possibilities are, I want just give you the example of position 1. This carbon should get 1 2 3 4, and this will be 5, and then this carbon will get 6, and we have to always count the carbon in the parent chain, right? So 7. If we count like this will be 7, and the position will be 3 for one methyl and 5 for another methyl. That means 3 and 5. All right, 3 and 5, one possibility. And another possibility is when we start counting from this end. Okay, so it will get 1, and it will get 2, and it will get 3. All right, 3, and it will get 4, and it will get 5, and it will get 6, and it will get 7. All right, so 7. Okay, from this end, 1 2, no, this is not 1 2 3. Okay, 1 2 3. All right, this should be 1, right? It should be 1. Okay, 1 2 3. That means 3 and 5. So from either side, the CS3 2 CS3 group will get 3 and 5 position. That's why 3 and 5 is the correct one. 3 and 5. All right, so that's why the name is 3,5-dimethyl heptane. So we can write the full name, that is 3,5 di, after the position we should provide the rest, diamide as well, methyl heptane, HEPTANE heptane. That is the name of this compound. All right, so this is how we can write the name of the organic compound. All right, so now I want to give you another example. Let's just move to another question. The question is over here. Okay, so let me give you an example of this question. Okay, I will just pick that question over here. This is the question. Okay, so let's just try another question to practice the name. All right, so the question is this. Okay, so for this question we have to determine whether there is branched polyfunctions or halogen or ether. Okay, so here we have COOH group, one group, and OH group, two functional group, and CS3, and this is CS3. All right, so that means there is a branch and two or more functional group. That means once we have a two or more functional group, then we use polyfunctional rule, and according to polyfunctional rule we should choose one functional rule as a principal functional group, and that principal functional group should be indicated by the secondary suffix. So we have OH and COOH, and in between them COOH gets priority according to the priority order, right? So that means COOH will get the priority and will be indicated by the secondary suffix here. So if COOH is indicated by secondary suffix and is considered as principal functional group, then we have to take the chain which contain the COOH group as a parent chain. That's why the parent chain will be like this. Okay, so this will be the parent chain. All right, this will be the parent chain, and then the remaining part will be the substituent. Here OH acts as substituents and CS3 acts as another substituent. All right, now once we determine this, we can move through the writing of the name. All right, so let's first write prefixes. Okay, so there are two prefixes, OH and CS3. For CS3 we have methyl, and for OH, if OH comes as a prefix, then we write hydroxy. So hydroxy and methyl, so we need to follow here the alphabetical rule, and alphabetically we first write hydroxy. All right, so hydroxy, and then methyl. All right, methyl, and then that is prefix. All right, and then word root. For word root we have 1 2 3 4 carbon, that is but, and then primary suffix we have single bond A and E, and here seems double bond, but this double bond is a functional group and which is connected with the which is present in between the carbon and oxygen. That's why this is not considered as a double bond. And when we talk about the nature of bond, we talk about the bond in between the carbon. That's why here is A and E. All right. And we have COOH group. For COOH group, we use oic acid. All right. That is secondary suffix. Okay. So this is the name. All right. Now here the secondary suffix, primary suffix start with vowel letter, so no need to add extra a, but secondary suffix start with the vowel letter. Here we have to remove the e of the primary suffix, right? And we have the rule that is e of the primary suffix should be removed. So hydroxymethyl butanoic acid, right? Now we need to provide the position of the substituents, and providing the position here we need to follow the lowest sum rule, and counting the number of the carbon starts from this end, because this is the principal functional group, and principal functional group should get the lowest number. So if we count from here, it will get one position, it will get, and then this carbon get 2 position, and this carbon gets 3 position, and this carbon gets 4 position. All right, so this is the correct counting. And now COOH group, oic acid gets 1 position, and which we can write over here. And then we have CH3 in 2 position, that's why methyl gets 2 position over here. Okay, and then hydroxy has 3 positions, so we need to give 3 positions. So the name will be 3 dash hydroxy, and then dash 2 dash methyl, 2 methyl, and then butanoic acid. Okay, we can skip the position 1 for okay, principal functional group, so we can just write butanoic acid. So 3 hydroxy 2 methyl butanoic acid will be the correct name for this compound. All right, so likewise you can also practice other questions over here. There are many questions categorized in different types, so you can also practice that. And that is all for this video, and thank you for watching. Bye bye.